Hello, in this lesson we are going to review of the exponential rules and introduce zero exponent and the negative exponent. So when we are talking about exponent, we need to know the power x to the exponent m. The m is, we call it exponent. And x, we call it base. When we multiplying so the whole thing we call it a power. When we multiplying or dividing the power, we could only combine the same base. So for multiplying two powers with same base, we are going to add the exponent. If we are dividing the power with same exponent, same base, we could subtract the exponent. And for the power of a power, we multiply the exponent. A product, then power, we apply this exponent to each factor of the product. For the division, we apply the exponent to the numerator and denominator of this quotient. So for example, 2 to the power 3, exponent 3 times 2 to the exponent 2, then this you have 2 to the exponent 3 means 2 times itself, 3 times. And 2 squared means 2 times itself, twice. So altogether you have 5, 2 times together, so 2 to the exponent 5. The exponent means how many times the base times itself. Then use a calculator. Is 2. On your calculator, you may have this button, exponent 5, or you may have x to the exponent y. This is the exponent button, then 5, the equal sign. It will give you 32. We call this evaluate. And for the 3 to the exponent 161 divided by 3 to the exponent 159, the denominator you have 159 threes, so cancel it 159 threes with a numerator, you will have only 161, take away 159, 3 left, so you have 3 squared. 3 times 3 give you 9. Then 10 to the exponent 2 times itself 3 times, you will have 10 to the exponent 2, 10 to the exponent 2, then times 10 to the exponent 2. So 2 plus 2 plus 2 give you 6. It's same as 2 times 3 equals 10 to the exponent 6. Then use your calculator, you will have 1, then follow with 6 zeros. And for the product power is 2a squared times itself 3 times, so you have 2 times itself 3 times, and a squared times itself 3 times, so you have 8 and a to the exponent 6. And for the division, we want to simplify the division first, so 2xy over y squared. 2x then y divided by y squared. We have 1 y cancel out, so 2 minus 1 give you 1. So you have 2x over y to the exponent 3. 2x over y times itself 3 times. You apply the 3 to each factor. So 2 cubed, x cubed, and y cubed. You have 8 x cubed, then y cubed. So this is a exponent laws you need to remember. And also when you have x to the exponent n as a denominator, the denominator couldn't be 0, so x couldn't be 0. And same thing, if y as a denominator, then y couldn't be 0. They are the restrictions. Then we are going to apply those rules to these expressions. So write each product as a single power. Single power means one base and one exponent. So this one we have 2 power times together, you have the same base. Then we could count how many 3 there. This one you have 4 threes, this one you have 5 threes. So add them together is 4 plus 5. Is 3 to the exponent 9. It didn't ask you evaluate, you could just leave it there. So this one we call it a single power. So one base and one exponent. So this is called a single power. The next one is division. So you have the same base. For division, we just cancel the denominator's exponent power out. So it's 13, take away 2, cancel 2 of the base out. Then you have 3 over 4 to the exponent 11. So this is a single power. Then this one is 2 over 3, the base. Then power to power is multiplication is 10. That is done. So the next one, you have more than one power. So 1, 2, 3, 4, 4 powers. So no exponent means it's 1. This is 1. So you have the same base. This in multiplication is 1 plus 4. Then you have division is subtract 3. Then you have multiplication again, it is plus 1. Then we are going to have 3 over 5. 1 plus 4 minus 3 plus 1 give you 3. It asks you to evaluate. Then we need to apply the exponent to numerator and also denominator. Then 3 times itself, 3 times 3 times 3 times 3 is 27. 5 times 5 times 5 is 125. So this is the answer for this one. And here we are going to do numerator and denominator separately, then do the subtraction, do the division. So this is multiplication, add the degrees is 9. Denominator is multiplication, add degree, the exponent is 8. Then division, the exponent subtract. Then we have 3. So the last example 3, simplify then evaluate. So this one you will see you don't have the same base. If we don't have same base, we couldn't apply the exponent laws for multiplying, dividing. So we want to change these two to same base. So we want to change the larger number to the larger base to the smallest base. So the base 2 is the smallest. Then we want to see using the factoring tree to see how many 2 in 8. So 8 divided by 2 is 4. 4 divided by 2 give you 2. So the end of the branch of this factoring tree, they are the factors for 8. So you have 2 times 2 times 2 times 3 times is 2 cubed. Then we rewrite it. So this one 2 power of power, you have 12. Then divide by 2 to the power 3, then cubed. So 2 to the exponent 12 divided by 3 times 3 is 9. Then it's division, we subtract the exponent. Then we have 2 cubed. Then it asks you to evaluate, it is 8. So it not only asks you to evaluate, but also simplify. So you need to simplify it to single power, then evaluate. And this one, we want to change everything to the same base. We want to change everything to the small base. So 25, we find the factor of 25. 25 divided by 5 give you 5, so we know 25 is 5 squared. 5 times 5. The end of the factoring tree, they are the factors. Times together give you 25. Then to the exponent 4 divided by 5 to the exponent 9. Then we have 5 to the exponent 3 times 5 to the exponent 8. Then divide by 5 to the exponent 9. So multiplication, we add the degrees. Division, we subtract the degree. So we have 5 to the exponent 2. Then evaluate is 5 times 5, 25. So that is for example 1, 2, 3. And we have seen that all the exponents are positive integers. And next page we are going to introduce exponent 0 and negative. So for the 0 exponent, x to the exponent equals 0 equals 1. The reason for that is if we have x squared divided by x squared, we know they are same numerator, denominator, you will have 1. But if we apply the division quotient rule, then for division, the exponents will subtract. Then you will have x to the exponent 2 minus 2 give you x to the exponent 0. So then we know that the same thing divide give you 1 and exponent is 0. So that's the reason x to the exponent 0 always equals 1, because same thing divide. So 2 to the exponent 0 is 1. And the negative exponent is just, we could think that x to the exponent negative n equals x to the exponent 0 divided by x to the exponent n. So 0 minus n give you x to the exponent negative n. And x to the exponent 0 is 1. So you will see that the positive and negative exponent, they are reciprocal to each other. So 2 to the exponent negative 2, we could write it as positive exponent and the flip. So we have 1 over 2 squared give you 4. So the bottom just, the following just the practice on simplifying the expression, and we don't want to see negative exponents, so we want to change the negative exponent to positive exponent. Then evaluate. Evaluate means you need to use your calculator to find the final answer. You could write it as a fraction, but no exponent. So this one is 2 to the exponent negative 4. Then we know that the negative exponent and the positive exponent, they are reciprocal, so we just flip it. Then we have 2 to the exponent 4, 2 times 2 times 2 times 2 times 2 times itself, 4 times, give you 16. And this one, 1 over 3 to the exponent negative 3, so negative exponent is reciprocal of its positive exponent, so we just flip it. You will have positive exponent 3. Then 3 times itself, 3 times give you 27. So negative 2 to the exponent negative 3, then it's reciprocal, negative 2 to the exponent positive 3. Then use your calculator, you will find out it's negative 8. And example 2. So this one, we know that is a negative exponent will be the reciprocal of the positive exponent. So reciprocal of it, we could just flip this. Then if we apply the squared to numerator and the denominator, you will have 3 to the exponent 2 divided by 2 to the exponent 2. So by default, the no degrees means 1. So 1 times 2 give you 2, 1 times 2 give you 2. Then we evaluate. 3 squared is 9, 2 squared is 4. Then this one is negative exponent. We are going to flip the base. So 4 over 1 to the exponent 3. Then it will be 4 to the exponent 3. Then it will be 64. 1 over 4 to the exponent negative 4. Then the negative exponent is a reciprocal of the positive exponent. So we flip it. You have 4 to the positive exponent 4. Then it will give you 256. So example 3, write each expression as a single power, then evaluate. So they have the same base. We just need to apply the exponent rules to combine them to a single power. So 5 to the exponent negative 3, then squared, we are going to power of power is multiplication, is negative 3 times 2. Then 5 to the exponent negative 2, all over 5 to the exponent negative 3. So 5 to the exponent negative 3 times 2 give you 5 to the exponent negative 6, then times 5 to the exponent negative 2 divided by 5 to the exponent negative 3. So we could do 5 to the exponent negative 6 plus, multiplication is plus, then division is minus. Then simplify, we have 5 to the exponent negative 5 with positive exponent for the single power, so we need to flip it. So continue, is 1 over 5 to the positive exponent. So negative exponent, positive exponents have the same base, they are reciprocal, so we flip it. Then evaluate 5 to the exponent 5, we have 1 over 3125. So the next one, example 4, we have the same base. We are going to just apply the exponent rules. Plus multiplication, then we add the degrees. And the division, we subtract the degrees. Then we are going to see 2 to the exponent negative 5. Get rid of the double sign. Plus minus, different sign give you negative. Minus minus give you positive. Then you have 2 to the exponent negative 4. Then we don't want to see the negative exponent. We are going to flip it. And its side, no, do not evaluate. We just leave it in this form, then it's okay. And the next one, it doesn't have the same base. We want to change everything to the smallest base. So 2 and 4, we want to change the 4 to the base 2. So 4 divided by 2 give you 2, so 4 equals 2 squared. Then we are going to use convert it. So 2 to the exponent 6 times 2 squared, then bracket negative 2 all over 2 squared negative 6. Then power of power is multiplication of the degrees. So times 2 to the exponent 2 times negative 2 give you negative 4. Then all over 2 to the exponent 2 times negative 6 is negative 12. Then multiplication we add, division we subtract. Then we are going to have 6 minus 4 plus 12. We have 2 to the exponent 14. Do not evaluate, then we stop here. So that is all for this lesson. So in this lesson, we reviewed the exponent rules, multiplication of the power with same base, we add a degree. If division, we subtract the degree. Power of power, we times the power exponents together. And if it's to the exponent 0, it will be 1. If negative, we could flip it to the positive exponent. Thanks for watching.